we have an opportunity to connect our curriculum to the real world. We need to explore these connections. Our students not always see these connections. How exciting it will be to make them realize these connections through physics experiments. And this is what we do in the physics lab here at Ahmedabad University. The pedagogical experiments, for example, the blank lab pedagogy which we have adopted in our physics labs here is very exciting as well as challenging, unlike the conventional physics labs which we see around in the universities. In the blank lab pedagogy here, our students, when they enter the lab, what they all see is just tables and chairs. There are no standard equipments. Of course, there are certain tools. They are given a one-liner physics theorem or physics objective to prove. They are divided into groups. They discuss the idea, they come up with a solution. They have to work on the experiment on a very modest budget. They utilize the workshop facilities here and they realize the experiment. They go in the workshop, they drill, they weld, they cut, they 3D print and laser engrave the objects and give them a shape and make them work in a working model. Through those, they conduct physics experiments, they quantify the errors and so on. One question is why we have adopted such pedagogy. One of the things is, as I already mentioned, that we need to make them realize the connections with the real world. Another thing is we force their brains, because when they do discussions, when they do class presentations, they cannot copy each other's idea. Okay. Also, they work on a limited budget, so they start looking around and seeing day-to-day objects as potential tools which they can use in their physics experiments. So there is collaboration, there is interdisciplinarity, and there are real-world connections in our physics labs.
Hi, this is Raghwinder Singh. I am faculty in School of Arts and Sciences. I work in the area of atomic and molecular physics. In physics teaching lab, we follow very different pedagogy. Instead of using standard experimental setup, we encourage our students to build their own experimental setup. For example, in a EM lab, our student build this setup. This is called Helmholtz coils. So in this experiment, student show the superposition of a different magnetic fields. So this setup is designed by our students. They calculated the thickness of wire, the diameter of the coils, and all this work is done in the university workshop.
So here you can see we have made an AC generator. Now current is coming through here which goes to the motor. Now this motor causes the magnets here attached to rotate. These rotating magnets create and changing magnetic field which is enclosed within the loops. Now these loops therefore generate electric current which is measured over here. Now we can see that as we change the current, the rotation frequency of the motor changes, and therefore the value of the changing magnetic field generated is more, and hence we get a higher value of the AC current produced over here.
This is Newton's cradle, and it's meant to demonstrate one of the fundamental laws that we use in classical mechanics, the law of conservation of mechanical energy. Although the law is only valid in an isolated system, where there is only the system and nothing else around it, not the air between the particles, but we can see the law when I pull this bead back and drop it, and we see the energy being transferred to the other end of the cradle. So when I think about the lab, I remember something a friend of mine said a couple of days ago. He compared doing this lab for physics as going to a museum as a student of philosophy. And honestly, where else would you get that kind of perspective? But he was also the person who was my partner in my first experiment. And I still remember we were there and we were supposed to prove this law of parallelogram law of vector addition. and we were looking at an eraser, and we were like, if you push it there, where will the friction go, and what will be the angles? And that's honestly one of the best things that you get from here. It's a whole different kind of learning, and we were clueless before, and we're less clueless now. But it's not as simple as just learning a concept, and it's not as simple as just applying it. You have to come up with your own ideas, you have to express them, you have to present them, and it's beautiful how you come up with new ideas and implement them through just talking. You can talk to your professors, you can talk to your teaching associates, and it's the most wonderful thing.